Welcome everyone to this new episode. We are about to get SSH access. We've been able to discover blindly using a remote code execution vulnerability the name of the user. This user was vulnerable because we were able to write inside its home directory. And now it's time to get SSH access. Let's get started. So we've been able to create .ssh, and now we want to echo, to make things a little bit better. I'm going to just undecode the entire thing so that you can see better. So I'm going to echo the content of my key inside these double quotes, and I'm going to redirect the output to that file, authorized keys. And this is where I'm going to put my public key. So let's get back to our box and cat.ssh and then id rsa dot pub. In goes our key. Let's put it right here, encode everything, and then send it. If everything goes well, it should take 3 seconds to run. Perfect. So now we have our public key. We can SSH into the server, SSH with the name of the user, which is nothing but our W3 for user HTTP only, at CTF15, and hit enter. Since we are using IDRSA, it's going to automatically take that into account, but what a bummer. It seems that it's not taken into consideration. If I type -vvv for verbose, so we can see here that indeed our private key has been offered, but we receive a packet type 51, which means there is some kind of error. And so because this didn't work, then the remaining method was password, and hence we are prompted with a password. So essentially, this means that the private or the authorized key file should be somewhere else, that there is a file that defines this property, and that's the sshd config. Let's explore it. So it's generally under etc ssh and sshd-config. Now, if I look for authorized, as you can see here, the first line, authorized key file, and I have a bunch of candidates. So by default, it can be under the .ssh of the user's home directory, but in this case, it's certainly not the case because we were not able to connect using our private key. So time to enumerate what is this value, and let's go back to our script. This is the part that needs to be changed. We need to grep inside the etc ssh sshd config. We want to look for anything that starts with authorized key. Let me just go back and verify real quick if that's indeed our value that we're looking for. So essentially that's authorized keys file. Okay, let's take that and put it right here. Okay, so we're grepping for that line in that file. And then I'm going to also pipe it to another grep. And here I'm going to look for anything that comes after that authorized keys file. That's what I'm going to put here. And so this is my placeholder. Now the script will go ahead and find the value of the authorized key file. Let's hope that it works. So let's remove that. We don't need it. So we are going to start on a fresh plate. Let's name it exploit2 and then run it exploit2.py. And let's wait. Okay, it found a space. Okay, there is a slash, typical for a path. I guess it's C. Let's play that game once more. Let's guess the next character. That would be slash. Correct. Okay, etc. Maybe under. Okay, S. The algorithm just beat me. SSH. Okay, SSH slash. Yes. Okay, the next one. A. Oh, 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 authorized. Yeah, maybe authorized. Yes, O. Okay. I guess it's authorized. Perfect. Maybe add a slash at the end. Oh, there's an underscore. Okay. Oh, authorized key. Yeah, maybe authorized key. Right. Y. Yes. And then a slash, maybe. Oh, S, authorized keys. Okay. So now, maybe a slash. Yes. Anything else? Oh, that's it. Okay, perfect. Authorized keys. Okay, so let's try that. So I'm going to go back to my previous command. Instead of storing my key inside home and then the user, I'm just going to put that inside here. So that's our path. So the path is /etc ssh authorized keys and then authorized keys file. I guess we don't need anything special here. Like it could be any value, but let's see. Let's send it. Oh, bummer. I get an instant response. This is not a good indication. Okay. Can we find more to that string? Because if you recall, we only use those characters. Maybe we could add something like a question mark, maybe a percent, and let's retry. Okay, let's see if we have more to the string than just the values that we've tested with before. So authorized keys slash, and then if we're lucky, we could get something else. Oh, we have a question mark. Another question mark. Yeah, I guess the question mark is here as a placeholder. It's not the question mark itself, so this is not really revealing. Okay. We could use the same exploit as before to enumerate the content of that authorized keys, right? Or maybe you can just guess. So generally, in a setup using multiple users, we could store the public key in the corresponding username. So we would have a folder with that user. So if I type das, then I send that, I get an instant response, meaning that maybe the user we don't have privileges to access that file. What about the second user, W3 for HTTP only? Put it right here and let's send it. Oh, it's taking some time. Oh, 3 seconds, meaning that indeed there is a public key that holds the user's public key inside this folder. So in the next episode, we're going to try that out and see if we can finally get an SSH access and then try our best to get root. As always, stay curious, keep learning, and go find some bugs.